All right, guys, we are moving on to our next unit, which is sequences and series. Sequences is basically just like patterns. So we're looking at different kinds of patterns that we can have, specifically arithmetic and geometric sequences. So we're going to talk about those today and how to write a rule or a formula for them. And just really kind of looking at the comparison between the two. All right, so in the do now, it says, can you recognize the pattern used to get from one stage to the next? So we see we have one smiley face, then we have 3, then we have 5, then we have 7, and then we have 9, right? So we see that we're adding 2 each time. Okay, so we can now use that and predict the next few stages, right? So once we know what we're doing to get from one term to another, we can continue the pattern. So basically a sequence is an ordered list of numbers. The sum of the terms of a sequence is called a series. So we're going to learn about that later. The terms of the sequence are referred to in the form below. So we use a lot of different notations in this unit, and sometimes the notations are what confuses people. So when I go through all this stuff, I'm going to go through all the notations that you should know, but sometimes you're going to be able to figure it out just because some of you are just going to be intuitively good at knowing patterns and recognizing patterns, and that's great. And you might be able to figure something out a different way than how I'm explaining it or showing it. Sometimes though we have to do things algebraically, and sometimes they just use the notations to say something instead of using words, and you have to know what those notations mean. So like here, it says the terms of the sequence are referred to in the form below. So the terms are 1, 4, 7, 10, 13, and 16. But see these subscripts on the bottom, A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. So when we do these sequences, I like to compare this to a parking lot that has parking space numbers painted on the ground. And then the terms are like the cars in that space, okay? So this is like the parking spot number. And these are like the cars in that spot. So A sub 1 means spot number 1 has a 1 in it. Spot number 2 has a 4 in it. Spot number 5 has 13 in it, right? So when we see this, we say A sub 5 equals 13. So when you see something that's written like that, you need to translate that in your head as, oh, the 5th term is number 13. Or in parking spot number 5, there's a 13 there. Okay, so that's what that means. The domain of the sequence consists of the location. So that's like the parking spot number. And then the range is the actual terms, like the cars. So, okay, an arithmetic sequence is an ordered list of numbers that have a common difference between each consecutive term. So D is the common difference. So really, you're adding, arithmetic sequence means that you're adding to get to the next term, and you're adding the same number each time. So it's not like you're adding 1 and then adding 2 and then adding 3. You have to be adding the same number each time. But if you're adding the same number each time, when you go backwards, that means the difference is the same. So that's why they call it the common difference. So like here, I have 1, 4, 7, 10, 13, 16. So I can just look at this and hopefully everyone can just see, oh yeah, it's adding 3. So that means that the common difference is 3. But if it wasn't so obvious, you could always go backwards and subtract, and it should be the same. So 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3, etc. So if you look at a pattern and you can't tell right away what it is going forward, you can always go backwards and see if the difference is the same. So here you have 15, 10, 5, 0. So you see it's going down by 5. So that just means that the D is negative. And again, if you went backwards and subtracted, you would see that the D is the same. 10 minus 15 is negative 5. 5 minus 10 is negative 5. So then we have here 1, a half, 0, negative a half, right? So it's going down again. So when the Arithmetic sequence is going down. That means the D is negative, and it's subtracting how much? Well, it's subtracting a half, it looks like, right? But even if I wasn't sure, if I went backwards and subtracted, it would be the same. 1/2 minus 1 is a half. 0 minus a half is a half. Negative half, sorry. Negative half minus 0 is negative half. Okay, so it's negative a half. All right, so that's arithmetic. So when you're adding the same number going forward, or when you go backwards and you subtract, the difference is the same throughout. Then we have geometric. So let's see. So an ordered list of numbers that have a common ratio R between each consecutive term. So to find the common ratio, divide the last term by the term before it and repeat the step for all terms. So again, it's really what you're multiplying, or when you're multiplying by the same number. And again, it can't be multiplied by 2, then multiplied by 3, then multiplied by 4. It has to be the same number that you're multiplying by. So like 5, 10, 20, 40. So I can just look at this and say, oh, it's doubling. So I know R is 2. But if it wasn't so obvious and you weren't sure, if you go backwards and divide, you should get the same number. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So that's how you know it's a geometric sequence, and R is 2. If it was dividing and you're getting different numbers every time, then it's not a geometric sequence. When you have the negative and the positive, that means R has to be negative, right? Think about when you multiply something by a negative number, it's going to change the sign, right? Negative times a negative is a positive, but then a positive times a negative is a negative. So it's going to alternate. So negative 11, positive 22. Negative 44, positive 88. So it's multiplying by 2, but it's alternating signs. So that means R is negative 2. So in geometric, a negative R means alternating signs. In arithmetic, a negative D means that it's going down, it's decreasing. And then here we have one that is a little bit more or less obvious, I should say. Right? So I'm looking at this and I see, okay, 4, and then 8 over 3, and then 16 over 9, and then 32 over 27, and 64 over 81. And if you look at it like separate numerator and denominator, this is 4 over 1, then it's kind of easier to see, like there's a pattern on the top and there's a pattern on the bottom. So you can see on the top it's multiplying by 2, and on the bottom it's multiplying by 3. So R is 2 over 3. But again, if you weren't sure just by looking at it, or you couldn't tell if it was geometric or arithmetic at first, you could always go backwards and divide. So if you divided 8/3 by 4, you get 2/3. If you take 16 over 9 and divide by the previous term of 8/3, you get 2/3. Okay? So that's really what you want to look for when you're looking at a pattern or a sequence. If it's arithmetic, you're adding a number, the same number, to get to the next term. If it's geometric, you're multiplying by the same number. Going backwards, arithmetic, you're subtracting. Going backwards, geometric, you're dividing, right? So those are going to be the main things you're going to look for. So now we have to determine whether a sequence is arithmetic, geometric, or neither. So not every sequence is one of these two. It could be a pattern, and it could be a predictable pattern, but it's not necessarily arithmetic or geometric. Remember, arithmetic, you're adding the same term or the same number to each term. Geometric, you're multiplying by the same number for each term. So neither, it could be a pattern, just not one of those two, right? So 144, excuse me, 72, 36, 18, right? So I'm seeing, am I adding or adding a positive or a negative to get to the same, or by the same number to get to the next term? No. Am I multiplying by a number? Now, some of you might be saying, oh yeah, I see it's dividing by 2, right? Which is true. But geometric is what you multiply by. So if you are dividing by 2, that's the same as multiplying by a half, right? So R is a half. So you don't want to say divide by 2, although that's, how you describe it, but the R value is a half. All right, so then we have negative 3, 4, 11, 18. Okay, so it's going up. Is it adding the same amount every single time? So I can go backwards and see if I get the same number. 4 minus negative 3 is 7. 11 minus 4 is 7. 18 minus 11 is 7. So this is arithmetic. And D is positive 7. It's going up. All right, then we have C, 9, 16, 25, 36. So I see a pattern. I see 9 is 3 squared. This is 4 squared. This is 5 squared. This is 6 squared. I could keep going because now I have this pattern. However, I'm not adding the same amount to get from here to here. I'm adding 7, then I'm adding 9, then I'm adding 11, which is a pattern in itself, right? But it's not the same number every time, so it's not arithmetic. And I'm not multiplying by the same number to get from here to here. If I go backwards and divide, 16 divided by 9, 25 divided by 16, 36 divided by 25, I'm not getting the same number every time. So this is neither. Okay. All right, so now we have two ways to express these sequences, and we have different formulas that we can use. So one is called the explicit formula, and one is called the recursive formula. So we're going to look at the explicit formula first. And these formulas are given to you on the reference sheet for the Regents exam. So you don't have to memorize them, but you should recognize them and know how to use them. So you need a different formula for each different kind of sequence. So for arithmetic, a sub n equals a sub 1 plus d times n minus 1. Okay, so what do these mean? So a sub n is the nth term of the sequence. What is the nth term? Well, it could be anything. It could be the 10th term, it could be the 100th term, it could be the 17th term. It's just like the spot number. And then a sub 1 is the first term of the sequence. N is the number of the term, so that's like the parking spot number. So a sub n is like the car, and n is the parking spot number. And then D is the common difference, okay? So this is a formula we would use to find a rule for arithmetic sequence, or to actually find the 100th term of an arithmetic sequence without having to find out every term. We can kind of skip to whatever term we need. And then for geometric, we have a sub n equals a sub 1 times r to the n minus 1, where again, a sub n is the nth term of the sequence. So a sub n is like the car in that spot. A sub 1 is the first term, and then n is the number of the term. So n is the parking spot number. So if it's the 100th term, n is 100. If it's the 100th term, a sub n is what car is in that 100th spot. What is that value? And then r is the common ratio. And one of the main things I want you to recognize, if you haven't already, is that this is linear, right? This is the equation of a line, basically, y equals mx plus b, where d is the slope. And then for geometric, this is an exponential. So because you're multiplying, right? So this, you're adding the same amount every time. This, you're multiplying by the same amount every time. So if you were to graph these sequences, an arithmetic sequence would look like a line, and an geometric would look like an exponential curve. Okay? All right, so let's see how we can use these formulas. So example 4 says, write the explicit formula. So when they say that, you're going to use one of these two. For the nth term, so that means that we don't know what term we want yet. We just want it to have an n in it. So this way, if I wanted to find a particular term, I'll just substitute the number in for n. So my formula is going to have an n in it. Of the sequence 1, 3, 5, 7, and then use the formula to find the 50th term. Okay, so I have my formula here. It doesn't tell me if it's arithmetic or geometric. So that's the first thing I have to figure out. Which one is it? So I see 1, 3, 5, 7. So it looks like it's adding 2 to get to the next term. Okay, so this is arithmetic. So that means that D is equal to 2. So I need a couple other things so I can write a formula. So when I'm writing a formula for the nth term, n is just staying n. So a sub n is just staying a sub n. n is just staying n. So I really only need a sub 1 and d. A sub 1 is the first term. The first term is 1. So a sub 1 is 1. So now I'm just going to plug this into this formula and create a formula. So a sub n equals a sub 1 is 1 plus d is 2 times n minus 1. So technically, this is it. This is the formula that I could use. Now I can clean this up a little bit. I can distribute this too. So a sub n equals 1 plus 2n minus 2. And then these are like terms. So now I have 2n and then 1 minus 2, so minus 1. And now it looks more like an equation of a line, right? So a sub n equals 2n minus 1. So this is my explicit formula. Now what's nice about this formula is that I can now use it to find any term in this sequence. So they want the 50th term. Now, I mean, I could sit here and just keep adding 2 until I get to the 50th number, but that's going to take a while. So this formula lets me just jump right to the 50th number. And n is the parking spot number. 50 is the parking spot number. So I'm going to let n equal 50. A sub n is the number that's in the 50th spot, which is what I don't know. So I have to figure that out. So I do 2 times 50 minus 1. So that's 100 minus 1, so 99. So in the 50th spot is 99. Okay, so this is what's nice about the explicit formula, is that you can use it to just jump to whatever term you need to find. All right, let's try another one with geometric. So example 5, write the explicit formula for the nth term of the sequence 1, 5, 25, 125, and then use the formula to find the 8th term. Okay, so same thing. First I have to decide, is it arithmetic or geometric, so I know which of the two formulas that I need to use, right? So I see here, it looks like it's increasing by a lot, or a different amount each time. So I'm gonna think, okay, it's probably not arithmetic. So I'm trying to think of what does it multiply by to get to the next term. So 1, 5, 25, 125. So it looks like it's multiplying by 5. If I wasn't sure, I would go backwards and divide. So 5 divided by 1 is 5. 25 divided by 5 is 5. 125 divided by 25 is 5, right? So if you can't see it going forward, then you can calculate it going backwards. So r is 5. And then again, for my formula, I want the nth term, so I'm going to leave n, I'm going to leave a sub n. So I only need two things. I need the first term and the r. So a sub 1 is the first term, which happens to be 1 here too. That doesn't always happen. It just, in these two cases, it just happens to be the first term is 1. So now we're going to write a formula. So I'm just going to plug it in. So a sub n equals, the first term is 1, times the r is 5 to the n minus 1. And that's my formula. 1 is like the a, right? This is like the b, and then to the n minus 1. So this right here is just obviously multiplying by 1. So even if you just wrote like 5 to the n minus 1, that's the same thing. So now they want the 8th term, right? So I'm going to let n equal 8. Now you might be saying, well, it's only the 8th term, so I could just keep multiplying by 5 until I get to the 8th number. Absolutely. If they don't tell you to use the formula, then you can just definitely keep going and write the pattern yourself. But something like here, 50th term or 100th term, that would be annoying. For this, you kind of have an option, but they did specifically say to use the formula. So a sub n equals, or a sub 8 I should say, a sub 8 equals 5 to the 8 minus 1, which is 5 to the 7th power, which is 78,125. So obviously you could see here, and I should have written a sub 50 here, by the way. So obviously here, it's the 50th term is only 99. Here, the 8th term is already 78,125. And that just, again, because this is linear and this is exponential, right? So we know that these are going to grow much faster because you're multiplying. Okay. Okay, example 6. Find D if a sub 2 is 6 and a sub 6 is 30. All right, so because it says find D, let me just make sure it's not blurry. Then you know it's arithmetic. If it's R, then you know it's geometric, right? So there's a couple ways to do this. I could set up two equations using my explicit formula and then solve those two equations for two unknowns. So basically a system of equations. That's a possibility. I like to kind of draw it out. Okay, so that's what I'm going to show you to do. So a sub 2 means the second parking spot has a 6 in it. And the sixth parking spot has a 30 in it. So that's what I'm going to draw. Okay, so here's a sub 2. Second spot has a 6 in it. 3, 4, 5, 6. So the sixth spot has a 30 in it. Okay, and it's D. So that means that I'm adding D to get to the next term. So I add something to 6 to get this. I add something to that number to get this one. I add the same thing to get this one. And I add the same thing to get 30, right? So to get from 6 to 30, I had to add the same number 4 times, right? Which also happens to be the difference between 2 and 6, right? So what is the difference between 30 and 6? So let's go backwards. So 30 minus 6 is 24. So I have to add the same number 4 times to get 24 worth to get from this spot to this spot, right? So we can essentially say that 24 is equal to 4 D's because I added D 4 times. So what could I add 4 times that would get me 24? And that would be 6, right? So D is equal to 6. So let's test it out and see if it actually works. So if I add 6 to 6, I get 12. If I add 6 to 12, I get 18. If I add 6 to 18, I get 24. And if I add 6 to 24, I get 30, so it worked. So D is 6. Now some of you might say, oh, well, I just kind of guessed and checked and it worked. That's fine too. And sometimes that's all you need. But sometimes it's not going to be as obvious, or sometimes it's not a whole number. Or sometimes it's going to be, a big difference in the spots. It really just depends. But that's one way that you could do it. Subtract this spot minus this spot, and that gives you how many D's you're adding. And then subtract this minus this, and that's how much value you need to jump from here to here. Okay. The alternative, like I said, is to make 2 explicit equations with your n and your a sub n and your finding your D and your a sub 1. It's just a lot more complicated. Okay, this is what I like to use to answer those kinds of questions. All right, then example 7 says the common ratio R. So again, this tells me that it's a geometric. Given a sub 3 is 3 and a sub 6 is 1/9. Okay, so I'm going to do the same thing. So third spot is 3. 1, 2, 3. A sub 3, there's a 3 there. And then 4, 5, 6. So a sub 6, there's a 1/9 there. Okay, so now this is a common ratio. So now I'm trying to think of what do I multiply this by to get this, and then that by R again to get this, and then that by the same thing to get 1/9. So first thing I should really recognize is that it's getting smaller. So that means I'm multiplying by a fraction because I'm going from 3 down to 1/9. So I already know that R should be a fraction. Then I want to kind of do the same thing I did up here, go backwards. But remember, this is arithmetic. So when you go backwards, you subtract. This is geometric. So when you go backwards, you divide. So you really want to say, okay, I have 1/9 and I'm dividing by 3. And that is equal to how many R's you multiplied by. Well, I multiplied by r 3 times. R times r times r is r cubed. So r cubed is really equal to 1/9 divided by 3. If you put that in the calculator, that's actually 1 over 27. So r to the third is really equal to 1 over 27. So if I want to find just r, I'm going to have to get rid of that cubed. So I can either raise it to the 1/3 or cube root it, right? So if I raise it to the 1/3, it cancels it out. Raise it to the 1/3. So that means that r itself is a third. So let's test it out and see if it works. So multiply 3 times 1/3, and that's going to be 1. Multiply 1 times 1/3, that's 1/3. Multiply 1/3 times 1/3, that's 1/9. So it worked. So again, you could do guess and check, but this one might be a little bit more tricky to guess and check, because are you going to guess 1/3 the first time you're doing this? Maybe not. Up here, could you have guessed 6? Probably. Down here, you're guessing that you're multiplying by a third? Maybe not on the first guess, and that might take you a while. Okay, so again, I could have set up a system of equations. I could have let, the third, the n be 3 and the a sub 3 be 3, and the n be 6 and the a sub 6 be 1/9, and then done a system. And it's just a little more complicated sometimes to do that. All right, so go ahead and give the practice a try and the homework as well, and I'll post the answer keys, and let me know if you have any questions. Have a good day, guys.